Welcome to this introductory tutorial on processing. If you're watching this video, it probably means you're either in my class or you stumbled across this and are interested in learning a little bit more about this programming language called processing. The materials that we're going to be following were produced by Professor Jeff Nyhoff of Calvin College, and they're being presented by me, Tim Stapert, a teacher at Grand Rapids Christian High. I think before we dive into actually using the processing, I think it makes sense to look a little bit at where processing came from and why we're here. And to understand it, really, we should start with the early visions of computing. I mean, when personal computers were first coming out, when Steve Jobs was developing Macintosh 1, the idea of computing and the idea of programming was kind of analogous to Legos. You know, somebody might write a program or might build something with Legos, and they might give it to you, and you might use it for a little while. You might play with it, but then eventually you'd take those Legos apart and you'd rearrange them a little bit differently, and you'd have a different program or a different toy if you're using Legos. But so the idea was that programs would be, fairly simple. You'd have these kind of building blocks that you would use to create whatever program you wanted. Unfortunately, nowadays, and somewhere along the line, programs became something that could only be developed by professional programmers. They're impossibly complex. They're unattainable to the masses. I mean, these are complicated programs. And while they are powerful and able to do a lot of really cool things, they're also limiting. If I have one of these programs, I'm not going to, and it doesn't quite do what I want to do, well, either I have to wait till there's an update that allows me to do something different, and then I have to repay for the program, or I find a different program and pay for that. They don't really allow me to actually go in and change the program to make it do what I want it to do. As we move to the future, though, we're starting to see kind of this resurgence of simple programs, apps, as we like to call them. Instead of computer applications, we can just refer to them as apps. And they're these really small, simple programs that are fairly easy to write and allow us to do whatever we want. And the Apple App Store is kind of a testament to this. You'll see thousands of apps, thousands of these simple programs, and not all of them written by professional programmers necessarily. So the future wouldn't be surprising to see more and more people writing their own programs again. And so that's kind of in light of what one of processing's goal was to, as you can see on this slide here, one of their goals was to act as a tool to get non-programmers started with programming. And you get this instant gratification of visual feedback. But the other thing that we should mention with processing, it was created by Casey Reese and Benjamin Fry, who were working in the Aesthetics and Computation group at MIT. And what they saw was that, more and more art was going digital. And they wanted to create a usable software interface that well, as you can read there, that would serve as a software sketchbook to teach fundamentals of computer programming, but also allow digital artists a little more control and a little more capability and a little more comfort level with computing. So that's kind of where processing began. So before we go much further, I do want to talk about this idea of programming too, because it's a little bit unfortunate that programming has taken on this connotation of something that's just horribly complex and hard to do, and you have to have at minimum a 4-year degree to be able to even approach this. At its heart, what programming really is just a list of events. Just like if you went to see Phantom of the Opera and you got a program, that program would tell you, well, first they're going to sing this song, and then they're going to sing another song, and so forth and so on, all the way down to the end. Well, that's all a computer program is it's a series of steps that the computer must follow. And if we can think of programming in that context, maybe it won't seem quite as intimidating. All right. At this point, you should all jump over to processing.org. If you haven't already downloaded the program, or if you're working at school and you have it, then you're fine. But if you ever want to be working at home on this, you need to download Processing. It's a free open source programming language. So, you can come here to processing.org, download the program, and get started. There's also a lot of tools on processing.org for reference, some tutorials, etc., that you might want to take advantage of. The other website that I would direct you to is this openprocessing.org. In the spirit of open source software, this is really a community where people can share their various sketches that they've come up with. So not only can you scroll through here and find a whole bunch of cool sketches and play around with them, more importantly, you can also come over here and look at the code. You can borrow this code, you can make modifications to this code. The idea here is that why does everybody need to reinvent the wheel? Why don't we share what we've created? And that way, if I want to use some of this code or part of this code, it can help me learn, and it can help set me on the right direction. So I encourage you to come check this out. Furthermore, you can also use Open Processing to create a sketch. Now, you don't have on here the full capabilities that you do in the downloaded program, but if you want to write your own program, you could write it here, click Run, and get the little window up above and see exactly what the program does. So at this point, hopefully you've got Open Processing downloaded, and you can open up a new sketch. When you open it, there's a couple things that we want to do before we do anything else, and so I'd encourage you to open this up and then come down here to Preferences. Now, I've already changed my preferences, but a couple things that you're going to want to do. First off is you're going to want to choose where you're going to be saving these sketches, and I created my own little processing folder where I'm going to save a few different sketches. So I would create a folder where you're going to save them. You might want to change your font size to make it a little more readable, and you're going to want to check this box to have a smooth text in the editor window. And both of these things require you to restart processing. So after you've clicked OK, obviously I canceled because I've already done it, but you'll need to reopen processing. So once you're there, I would encourage you, if you've got access to it, if you're in my class, to take a look over at this handout. It's available on our Moodle page. But again, it was produced by Professor Jeff Nyhoff. But we'll follow through this, and we'll start on page 1 here, and we'll work our way through all the different pages that he has available for us in further parts of this video series. So our first thing that we need to know about processing is that when we are typing in commands, just like in the English language that you end every sentence with a period, here you must end your commands with a semicolon. So for instance, the first command that we're going to be talking about is this size command. So if I'm doing a size 400, 200, I have to end it with a semicolon. If I don't put that semicolon in, processing isn't going to know exactly what to do. The other note about how we type our code is that spaces don't matter. So if I put a couple spaces in because it looks a little bit nicer, it's not going to cause the code to work improperly. Lastly, and this is kind of a this is pretty common for most programming languages, there are a lot of predefined names and commands in processing, and they are case sensitive. In other words, if I typed this as size like that, processing is not going to know what to do with that command. They need to be properly typed in, and spelling must be exact. If I type in size with two eyes, it's not going to work. And also one thing you'll often see, this is a command we're going to talk about in just a minute, but when you type a command that is actually 2 words long, like stroke weight, convention is that we would capitalize the second word. So those are a couple things to keep in mind. You'll become used to them in no time, but keep an eye out for those sorts of things, especially missed semicolons can often cause problems. So our first command is that size command. When we type that command in, so I typed in size 400, 200, gave it the arguments. It's going to create a canvas that is 400 pixels wide and 200 pixels tall. So if I click play, this run button, you can also hit Control R, it'll do the same thing. What it produces then is this little canvas for us that is 400 pixels wide and 200 pixels tall. And each one of these pixels, I know you can't really see them, they're really, really tiny squares in there, but each one is labeled with an X coordinate and a Y coordinate. So you've got 0, 0, and then you've got 1, 0, and 2, 0, and then 100, 0, and 200, 0, and 300, 0, etc. So it's a lot like in math class when you're drawing a graph. The only big difference here is that as you get bigger with your Y coordinate, you go further down. So here's 0, here's 100, here's 150, etc. As you're going down, the Y coordinate number is getting bigger. So keep that in mind as you're trying to draw different things. I'm going to actually close this little sketch, and we're going to move on to the next command here, which is called the point command, and it's really kind of a boring one, but you'd be surprised, it's actually fairly useful. A point, it's just going to draw a point, and we give it an X and a Y. So maybe I'll give it the point 10, 100. And so it should go 10 rows over and 10 columns over and 100 columns down, and draw me a little, my mouse stopped working. Hit Control R, we created this little sketch, and you can barely see it, but 10 rows over and 100 down, there, right there, is my little point that I just drew. Seems fairly useless, but for instance, one of the sketches that a number of students did at the end of our unit were related to Christmas, and they wanted to have some snow, so you might want to use that point command to draw a whole bunch of little points, white points that would look like snow. So the point could come in handy. The next command, though, is a line command. So as you know from your math classes, a line needs 2 points, and you connect them. So 10, 100, and let's do 300, 150. If I run that, I get this line that started at 10, 100 and went down to 300 columns over, 150 down, and drew a line between them. I'm going to jump down actually on our worksheet here down to this stroke weight command before we move on and talk about smoothing. The stroke weight command, like in a Microsoft Paint program or any other drawing program you may have used, stroke weight just makes the thickness of whatever you're drawing a little bigger. So if I put stroke weight 5, you'll quickly see the effect, and it makes a much thicker line. I think we'll stop here for now. We've learned the basics about how to some of the syntax using the semicolons, giving it the right arguments so that things work, and how to change the stroke weight. And we'll pick up with smoothing and a few other commands in the next segment. So join me for that.